Hello and welcome to Unit 1, Part 2. My name is Mr. Bell and today we're going to talk about solving one-step equations and then we're going to justify each step to solving those one-step equations. In order to justify certain steps when solving an equation, you need to learn some of the properties of equality. Let's take a look. The first one we'll talk about is the addition property of equality. Basically what that means is if you have two things that are equal, let's just say 5 is equal to 5. Well, the addition property of equality means that if I add 3 to the left side, as long as I add the same thing to the other side of the equation, you're still going to have a true statement. So the reason that 8 equals 8 when we were given 5 equals 5 in this particular situation is because of the addition property of equality. We added the same thing to both sides of the equation. The next property to talk about is the subtraction property of equality, which is really the same concept. Let's just say we start with 10 on both sides of an equation. Well, the subtraction property says that if I subtract 2 from the left, I've got to subtract 2 to the right, and that maintains the equality property of our beginning situation. Moving on to the multiplication property of equality, if I multiply the left side by 2, I need to multiply the right side by 2 to maintain equality. And the division property is stating that if I divide both sides by 2, I maintain my equality status. Now for some examples. Let's solve and justify with the properties we just learned. If we have a plus 10 is equal to 30, well, the opposite of adding 10 would be to subtract 10 in order to cancel it. And because of the subtraction property of equality, I need to subtract the other side by 10, leaving me with a is equal to 20. The reason that a equals 20 is because of the subtraction property of equality. Moving on to the one on the right, it says x minus 6 is equal to negative 3. I know that I would need to add 6 in order to cancel that negative 6 to get x by itself. Well, using the property, if I added 6 to the left, I've got to also add 6 to the right, giving me positive 3 as an answer. And the reason in this scenario that x is equal to 3 is because of the addition property of equality. Now we are given 5y equals 100, and remember when the 5 and the y are right next to each other like that with no signs in between them, it implies multiplication. To undo multiplication, we need to divide both sides of the equation. So we'll undo multiplying by 5 by dividing by 5. 5 divided by 5 is 1, which leaves me with just y. But if I divide the left side by 5, I've got to do it to the right side to maintain equality. 100 divided by 5 is 20. The reason y equals 20, the justification, is because of the division property of equality. On the right side, you got z divided by negative 4 equals 10, and to undo division, we need to do the opposite operation, which is multiplication. So I'm going to multiply both sides by negative 4 because of the multiplication property of equality. We wind up with negative 4 over negative 4, which cancels much like the 5s did in the previous problem. We're left with z equals. 10 times negative 4 gives me negative 40. The justification for z being equal to negative 40, is because of the multiplication property of equality. The last two that we're going to do are kind of special cases. On the left, we've got negative x equals negative 26. Well, we don't actually have x solved by itself. There's a negative in front of it. And a lot of times teachers will see this as negative 1 times x is equal to negative 26 because of the understood 1 in front of anything. To get rid of times negative 1, we're going to divide this side by negative 1 so that we're left with just x. And because of in this case, the division property of equality, we need to divide both sides by negative 1, giving me x is equal to 26 because of the division property of equality. And the last one, we have 1/3 times x equals 9. Now you could divide both sides by 1/3, but dividing fractions gets a little cumbersome. Another way to think of it is to multiply by the reciprocal. The reciprocal of 1/3 is just its flip when you flip it around. This would give you 3 over 3, which cancels itself to be 1, leaving you with x. However, if you multiply the left side by 3 over 1, you've got to multiply the right side by 3 over 1, giving you the result of 27 because of the multiplication property of equality. All right, thank you for watching and hope it helps.